Hi Grade 8! I'm Teacher Joshua, your mathematics learning guide here at DepEd TV. In the last few episodes, we showed how to plot points on the rectangular coordinate system. We learned how to graph the linear equation by identifying the slope and the intercepts. And we can find the equation of a line. Now, join me in new chapters of learning that would help us be critical and logical thinkers, as we use the skills we acquired to solve problems involving linear equations in two variables. Make sure that you have your self-learning module, paper and pen, and let's get started. The Philippines has been experiencing a lot of natural calamities like typhoons, earthquakes, and even volcano eruptions. And through this, even before the pandemic, we've seen Filipinos' very helpful nature and generosity. Aside from local government units, we also have non-government organizations and our fellow Filipinos thinking of ways to provide help to those in need. Do you remember Anna and Ben, who volunteered to bring the chairs for the charity program? This time, they wanted to help their community during this trying time in their own little ways by providing canned goods and rice was their project. Their goal is to provide a total of 120 canned goods. Do you still remember how we were able to set up the equation in this kind of situation? We let X be the number of canned goods Anna brought. Then we let Y be the number of canned goods that Ben brought. Since their goal is to have a total of 120, we write x plus y equals 120. If Anna initially brought 80 canned goods, how many more does Ben need to bring? Since we already know the number of canned goods Anna brought, we simply substitute the value of x as 80, and from that, we may solve for the value of y, which is 40. How about if Ben brought 52 canned goods? How many will Anna bring? Anna will bring 68 canned goods. We just subtract 120 minus 52. Before we start solving more problems involving linear equations, let us practice translating these sentences into a mathematical expression or equation. First, twice a number is 6. Let the number be represented by n. So this sentence can be written as 2n equals 6. How about this one? 4 added a number gives 10. It is 4 plus n equals 10. Let us try this. 25 decreased by twice a number is 12. This will be 25 minus 2n is equal to 12. Let us recall that the solution of an equation in two variables x and y is any ordered pair xy that makes the equation true. To determine whether an ordered pair xy is a solution of an equation, we simply substitute the values of x and y into the equation. Take note that the equations in two variables have infinitely many solutions and forms a line when graphed. Try these examples. Number 1. Given an equation 3x minus 2y equals 17, find x when y equals 2. We know that we have a linear equation since the degree is 1. There are two variables, the x and y, but there is a given value for y. Therefore, we can solve for the value of x corresponding to that value of y. We simply substitute the value of y equals 2 in the equation. 3x minus 2y equals 17. Thus, we have 3x minus 2 times 2 equals 17. Or simply, 3x minus 4 equals 17. Isolate 3x by APE or the addition property of equality by adding 4 on both sides. 3x minus 4 plus 4 equals 17 plus 4. This gives us 3x equals 21. Since we only need the value of x,
we multiply 1/3 to both sides of the equation.
And we will have x equals 7. Therefore, the value of x is 7 when y is 2. Now, what if we use the same equation, 3x minus 2y equals 17, but we need to find the value of y when x is negative 4? There are two variables x and y, and we know the value of x. So we can substitute it to the equation, then solve for the other variable, which is y. The equation 3x minus 2y equals 17 now becomes 3 times negative 4 minus 2y equals 17. Or simply, negative 12 minus 2y equals 17. Again, by the addition property of equality, we isolate negative 2y by adding 12 on both sides of the equation. That is negative 12 minus 2y plus 12 equals 17 plus 12. After simplifying, we will have negative 2y equals 29.
By the multiplication property of equality, we can multiply both sides of the equation by negative 1/2. Hence, we will have y equals negative 29 over 2 or negative 29 halves.
How about when we are given a condition where a number y is 5 less than twice a number x? What is the other number if x is 8? Let us set up first the equation. We have two unknown numbers, x and y. The condition is that
y is 5 less than twice of x.
So we have y equals twice of x, then subtract 5. We are asked what is the value of y when x is 8. We have to substitute the value of x to the equation, having y equals 2 times 8 minus 5. Then simplify. This gives us a value of y equals 16 minus 5 or 11. Therefore, if the unknown number x is 8, then the unknown number y is 11. Let us consider the same condition. A number y is 5 less than twice a number x. What is the other number if y is 7? We will consider the same equation y is equal to 2x minus 5. The value of y is known, which will be used to find the unknown number x. Substitute the value of y equals 7. The equation will be 7 equals 2x minus 5. To isolate 2x, add 5 on both sides by the addition property of equality. This gives us 12 equals 2x. By the multiplication property of equality, we multiply 1/2 on both sides to get the value of x. We obtain x equals 6. So we say that when y equals 7, then the other number x is 6. There are many possible cases that can happen due to the nature of linear equations, on its slope, intercepts, and even the points or its solution. Now, how about when we are asked for what values of x is y equals 5 in the linear equation y equals 5? This equation, having only one variable equate to a real number, means that for any value of x, y is equal to 5. That is why, when we try to graph its solution, we get a horizontal line. Let's try another example. Given 0, 3 and negative 2, 0, which are solutions to a certain linear equation, for what value of y is x equals 1, such that it is a solution of the same linear equation. Recall that a linear equation has infinitely many solutions, where they all lie on the same line when graphed. In this case, we do not know the equation, but we have the solutions 0, 3 and negative 2, 0. Observe that one of the given points, 0, 3, are the coordinates of the y-intercept. Do you still remember the slope-intercept form of a linear equation? It is y equals mx plus b, where m is the slope and b is the y-intercept. Since we know the y-intercept, we have y equals mx plus 3. But we still need another value to complete our linear equation, and that is the slope m. Since we have 2 points, we have a way to find the slope. We consider the change in y over the change in x. Take the points 0, 3 and negative 2, 0. The change in y will be 3 minus 0, which is simply 3, while the change in x is 0 minus negative 2, or simply 2. We have the change in y, 3, over the change in x, 2. Therefore, the slope is 3/2. Going back to our linear equation, y is equal to mx plus 3, this will be y equals 3/2 x plus 3. Now that we have the linear equation, we can now find for the solution where x equals 1. First, substitute the value of x equals 1 to the equation, which will be y equals 3/2 times 1 plus 3. Simplifying this, we get a value of y equals 9/2. Therefore, when x equals 1, y is equal to 9/2. The processes of solving equations discussed in the previous lessons are very helpful in solving problems involving linear equations in 2 variables, together with the skills of translating verbal sentences into mathematical equations. There are real-life situations that exhibit linear equations in 2 variables. The following steps can guide you in solving word problems. First, read and understand the problem, identifying the given and the unknowns. Second, write the equation representing the situation. Then finally, solve for the unknowns. Note that we may check the solution obtained by substituting the solutions to the original equations. Now let us solve this word problem. Jake is buying mangoes and bananas. At the market, a kilo of mangoes is 100 pesos, while a kilo of bananas is 50 pesos. His budget for those fruits is 500 pesos. Write the equation that represents the number of kilos of mangoes and the number of kilos of bananas he brought with 500 pesos. Next, how many kilos of bananas were he able to buy if he bought 3 kilos of mangoes? We are considering 2 things here: the number of kilos of mangoes and the number of kilos of bananas Jake bought. We may let x be the number of kilos of mangoes and y be the number of kilos of bananas Jake had. We know that a kilo of mango costs 100 pesos, while a kilo of bananas costs 50 pesos, and the total spent for those is 500 pesos. Therefore, we will have the equation the cost of the mangoes per kilo times the number of kilos of mangoes plus the cost of bananas per kilo times the number of kilos of bananas he bought. Then it is equal to 500 pesos. We have a linear equation in 2 variables. and we may use the equation to answer the other question. In this condition, we know the number of kilos of mangoes Jake bought, or the value for x. The unknown is the number of kilos of banana bought, which is the variable y. With the help of the equation, 100x plus 50y is equal to 500. Simply substitute the known variable, in this case, x equals 3. The equation now is 100 times 3 plus 50y equals 500. We proceed to solving for the value of y. This is now 300 plus 50y equals 500. By the addition property of equality, we add negative 300 to both sides of the equation. 300 plus 50y minus 300 equals 500 minus 300, which is simply 50y equals 200. To solve for y,
We multiply both sides by 1 over 50.
and we will have y equals 4. Therefore, when x equals 3, then y equals 4. Since we know that x represents the number of kilos of mangoes, and y is the number of kilos of bananas, we conclude that with 500 pesos, when Jake bought 3 kilos of mangoes, he was also able to buy 4 kilos of bananas. Let's try this problem. Melissa was asked to buy packs of sandwiches and lunch packs as additional food to be prepared during the charity work. With her money, she can buy 10 lunch packs without packs of sandwiches. But she can buy 40 packs of sandwiches without lunch packs. If she bought 8 lunch packs, how many packs of sandwiches can she buy with her remaining money? In this problem, we are considering two things again: the number of lunch packs and the number of packs of sandwiches. We may represent x as the number of lunch packs, while y for the other. This time though, we do not know how much money Melissa have or the price of each pack. But we know the quantity of packs that she may buy. Will that be enough information? Let's analyze. If she buys 10 lunch packs, then she cannot buy packs of sandwiches. That can be when x is 10, then y is 0. While if she buys 40 packs of sandwiches, she cannot buy lunch packs. That means when x is 0, then y is 40. We actually have two ordered pairs here, 10, 0 and 0, 40. With this, we may set up the equation. Observe that we have a y-intercept with the coordinates 0, 40. Therefore, we may use the slope-intercept form because we now have b equals 40. Next, we just need to find the slope, and that is 40 minus 0 over 0 minus 10. And this gives us a slope of negative 4. Since we have b equals 40 and the slope m equals negative 4, the form y equals mx plus b gives us an equation y equals negative 4x plus 40. With this equation, we may now solve for the unknown. We are asked how many packs of sandwiches can she buy with her remaining money if she bought 8 lunch packs. From this, we have x equals 8 and the unknown is the number of packs of sandwiches, which is y. The equation y equals negative 4x plus 40 becomes y equals negative 4 times 8 plus 40. Simplifying this, we will have y equals negative 32 plus 40, or simply y equals 8. We can now conclude that if Melissa buys 8 lunch packs, she may still buy 8 packs of sandwiches. There are lots of situations that we may actually form a linear equation to help us solve the problem. Remember that we must read and understand first the problem. Analyze to set up an equation. And when we were able to form a linear equation, we simply apply all of our knowledge and skills we acquired from the previous lessons related to solving linear equations in two variables. A lot of possibilities and ways to solve a problem, as long as we understood what is happening and have the necessary knowledge and skills to manipulate and solve for the unknowns. Keep on practicing so you would be ready for more applications of these lessons. And you will find that they are actually fun, easy, and useful. I know that you will be math masters in just a matter of time. And if you find the topic difficult, you may consult your self-learning module or visit the DepEd official YouTube channel and review our lessons. That is our last lesson regarding linear equations in two variables. I hope that you learned the most basic to the more complex ideas in this topic. Next episode will be the start of the last chapter for the first quarter, the system of linear equations in two variables. With that, this is Teacher Joshua reminding you to practice, practice, practice. Do it with a positive attitude and a smile on your face. See you again for a math terrific day, because here at DepEd TV, we will never let your learning hindered by anything.